to start.
All right. Yeah, I mean, I guess I can go first here. So, as I pointed out yesterday, or not yesterday, like the day before or something, I kind of figure out the final details of how the WebAssembly and non-WebAssembly platforms tie into one another. So those are the last details I'm wrapping up. There's some runtime aspects that I was talking about to Luke, but that I'm going to punt on and just get the compiler parts of it done first. So we won't have support for WASM initially, but just be a matter of adding in those runtime hooks. But yeah, that was kind of the last major blocker, really, from my perspective. I was uncertain how we were going to be able to tie that stuff in. But after doing some research and looking at how some, other people have been talking about doing those implementations, I think I found a pretty good solution for that. So we'll see how it performs. I'm still not certain that it's going to be great. The only real measurements of this have been done in the context of Asyncify, and the overhead there and space was like, I think, up to double the amount of space required without Asyncify. And performance-wise, it seemed like it was maybe 50% slower than without it.
Are we moving fully away from using the host stack? Are we just using like a base stack instead?
What do you mean? Like on
what was the approach you landed on? Yeah, on WebAssembly.
So it's kind of like a fibers like primitive. So you have sort of a U context like thread context, which really is going to be melded together with our process structure. And then inside that you have a shadow stack and a continuation stack. So instead of using the native stack for WebAssembly allocations, we use the shadow stack for that. And then the continuation stack is more or less a set of activation records that record all the continuation data and the state index of each continuation function. So every time you push another continuation frame on that stack, you know where it is, like which function is, where in that function to pick up control. And all of the locals are the stack like the stack pointer of the shadow stack when you are in that frame. That way you know when you pop a frame off how to get the stack back to where it was.
So just because I'm curious, when you have a function with like multiple suspension points, how would that be handled? Would it be split into several functions, or would it be one with like a resumption structure or something that?
It would be like switch-based resumption, so it's a single function split up into kind of a state machine. You can split up into multiple functions, but that was, and that's something that we could still theoretically do. The main reason why I chose not to do that is that it just complicates things like, debugging in stack traces and the like, where now your native traces no longer resemble like the actual functions that you want users to see. Instead, they see whatever you've named the variant functions. And there's maybe some ways that you can deal with that, and however you're generating the traces. But in our case, I really wanted to be able to rely on external tooling and not have to do too much of that ourselves. So in that case, the switch-based resumption works better. And it's in some ways simpler to program as well. For sure, it's easier to optimize, I think, because for the most part, the function is still a normal function, and you can do things like, move allocations up into the first stage of the function, and then when you resume control back in there, the stack is already set up, the locals are already initialized. Like, you can just pick up control where you left off.
Yeah, all the optimizations in LLVM still work. It's not like it's split into several. Yeah.
The main difference is that I won't be using LLVM's coroutine support for this. I don't think yet. The first stab at this does not use them. It may end up being that the interaction with other things will eventually require it, but I think it's actually simpler for us to handle the transformation ourselves. So that's the path I've taken.
Yeah, be careful using that, because there were bug reports about the coroutine functions. The annotations aren't correct. Like, coroutining is one of the
You're talking about the interaction with no alias, and that's not something that's a problem for us.
No, like the assumptions of like this call will always be the same, because it's assumed that coroutines can switch stacks, like they can work steal. And so if we ever get to a work stealing one, the current coroutine functions don't have the right attributes to. It assumes that like calls that like are annotated constant, like what is the local thread ID, can be lifted out and only called once, but a coroutine is supposed to be stealable. And so like there was a bug report about it a couple months ago that it doesn't do that. And so there's a discussion thread of like, well, if you don't use coroutines, saying it's constant totally works and is super optimized, but like they might need a new category of like, it is constant except if you're a coroutine, because you might be work stolen. So
I mean, I'm familiar with the thread and the discussion there, because I keep up on that stuff. And the particular problem described there is not really relevant to the way we're doing things currently.
Okay.
It's very specific sequence of things. In a general case, there's a soundness problem that they want to deal with, but it primarily deals with code that is dealing with like thread locals and statics, things that we're not really concerned with.
That won't bite us that we have thread locals for like how the scheduler does processes. I mean, I know that might kind of be going away because we're doing the features thing now, but
yeah, it was more like, the canonical example they were using was getting like the thread ID or thing, because that, once it's obtained, gets cached somehow, I guess, and then it sees the same thread ID even though it's been moved across threads. Something. Or
is it anything that accesses stuff in like the thread local block?
It's like thread ID is marked. I think the attribute is actually called constant. Like it's assumed that, or it's something like it, where like if it doesn't know that coroutines can move threads is what it came down to. But if
I know no alias is one of the poor interactions, and then the other one I think is like read only, something like that. Essentially, yeah, that's what it was. I'm pretty sure it's read only or one of those similar annotations. And essentially the assumption being violated is that annotation implies that the value cannot change from the perspective of the caller, but that does not hold with coroutines, where you can suspend and then resume, and that value has changed.
Yeah, it was it was like a loop optimization where it was lifting it out of past the resumption point up, and like, it'll only call it once because it's not going to change, and that was invalid.
Right.
Because the whole point of the code doing it was like to figure out which scheduler it was on.
And the reason why I was saying that it didn't apply is that because I was specifically, avoiding using that annotation on any of the functions that I was defining for us. And we weren't using the intrinsics that they were complaining about. But in theory, we would be affected if we wanted to use those attributes, or if we wanted to call a function that is either an LLVM intrinsic or is provided by like a libc or something that LLVM tries to optimize around using attributes like that. There's some functions that LLVM sort of like specially identifies kind of opaquely, and those might be tagged by that. But in our case, we don't actually call any of that directly from the generated code, at least the things that were identified in that initial discussion. Maybe it's evolved past that point now. It's been maybe a month since I last checked in on that.
Just because I'm curious, we're storing like scheduler info in a thread local, right?
Yeah.
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 More than just scheduler info, we store
Process
like the
too.
current process state, or the active process anyways. But the thing is, like, we enforce the semantics that those things do not change from the perspective of the generated code, because we don't annotate those things with attributes that imply something that doesn't hold. And we also ensure that before we ever resume a process that was already executed, that we restore all the state as it saw when it left off. The only thing that could theoretically change would be the thread ID that something is allocated on, but the generated code never cares about the thread ID. That's purely the runtime concern. I'm not even sure if we're actively using that anywhere right now. In a sense, like the thread local parts are static across threads, because that state that we restore and save goes with the process. It's not something that each scheduler has a different view of. So when a scheduler in a pool of schedulers takes a process and schedules it for execution, and it starts executing, like the view of the world it sees is the same as it saw on the last scheduler it was on. And in theory, the only thing that would be different is the actual reference to the scheduler. But those functions that we use to access the runtime, none of those we don't annotate them with anything that would cause LLVM to think of them as fixed. Like they're not decorated with like read mem or no read or read only, that kind of thing. We treat them as totally opaque, and that essentially tells LLVM that it can't optimize around those. In the future, I'd like to add more of those once we pin down the semantics a little bit more. But to avoid any sort of weird optimizer bugs like that, I stayed away from it.
Yeah, makes sense.
So with the runtime changes, I just want to confirm we would get rid of stack switching for all targets then.
We could. That was, I mean, yes and no. The thing that I want to get rid of that would go hand in hand with this is that currently we allocate like a thread stack.
Mm-hmm.
And then, that ends up being quite heavy. A lot larger than the equivalent Erlang process on the beam, just because of the size of the stack we need in order to call into the Rust runtime. So my thought there is that, the CodeGen perspective shares most of that representation. Then it becomes a lot easier for us to control, like on a particular target or set of targets or all targets, whether or not we want to use coroutines everywhere, or if we do kind of a blended thing where, the problem that we have on WebAssembly is we have to like unwind this whole stack and then rewind it all the way down. But on other targets, we can use assembly to jump straight out to the scheduler and straight back into where we left off. The thing that we could then share between WebAssembly and non-WebAssembly targets is where we allocate stacks, like locals. So in that case, we could use the shadow stack on all targets, share that code generation path, but then optimize the context switching on non-WASM targets to just do essentially like a simple context switch. If that makes sense. Did that answer your question?
Well, I'm like, if it has the future generator signature, isn't it always going to return up for it to work? Or like, it would say it has that signature, but we wouldn't actually return the way a normal generator would.
So to be clear, like the future generator stuff is implemented as traits. And so the only thing that holds or that has the hold is what you do when you either pull a feature or resume a generator. And the implementation of that is completely undefined. Like, it's up to us. So in our implementation of those things, then we can choose whether we want to do the like slower, rewind approach when resuming control, or if we want to just optimize that on targets where we're able to just switch back to where control left off.
Have you thought about stuff like, I don't know how much this makes sense, but like making calls into the rest runtime on like the thread stack, like just like switching the stack anytime you call into the rest stuff?
Yeah, that's another approach too, as well, if we want to, preserve using separate stacks for the processes.
I guess I'm not sure about the performance impact, but I just like I imagine we might be losing some like insight from LLVM2, like optimizability, if we like switch to doing a shadow stack, or I guess if it was implemented with like LLVM intrinsics, but in some way like custom intrinsics.
Yeah, it remains to be seen. One of the things here is that we can actually change the code generation strategy per platform pretty easily. The discussion I was having with Luke was really about, can we represent all like our scheduler in a way that's universal, but the actual implementation of like the traits here for future generators does things differently based on a flag, or however we want to choose to select the code generation approach. But because all this stuff is unified in the CodeGen backend, it becomes a lot easier for us to say, okay, well, let's do an experiment where we use the same coroutine strategy on x86 as we do on WASM and see how it performs. And if it's
that's a good point.
Fast enough, then why have different approaches? If we find that it performs really poorly, we can benchmark that versus kind of our existing strategy of having multiple stacks and switching between them. If we do the benchmarking and see that there's either not a noticeable difference or a huge difference, we can choose which way to go then. But the bigger thing is just the less of this kind of platform specific differences we have, the better. And right now we have a lot of complexity in our schedulers, but the schedulers are almost entirely separate. And that's largely due to the differences between the platforms. But, the deeper I got into developing the kind of back end for compilation that does both targets and kind of a shared context, I realized that, we can do the same kind of thing at a high level too in our runtime.
I guess regardless how we think about it, it makes sense to just go with this approach, at least like initially, and then if it turns out to perform like less well than we thought, then we can probably also have like a better impression of like what changes to actually make to get best performance. Yeah.
And one thing I was thinking is that if we're forced to use kind of a slower path on WebAssembly by using the same thing on native targets, we're also going to be a lot more sensitive to kind of the performance penalty there, and it might encourage us to optimize more to make things faster as much as possible. I'm not sure how much of that carries over between the targets because the way things get, optimized is going to vary quite a bit depending on how the browser engines handle that stuff. But, dog fooding it might be more useful there.
Yeah.
But I do want to get to a point where we can start, targeting WebAssembly directly, because I think that's still kind of our most compelling target.
So how do we make a generator of future wrappers? See, I know like the whole point of Waker being a vtable is to support like C implementations, but like how do we change the type signature of like the NIFs so that they work with this? Like it can't be just term none to indicate like look for a continuation because it has to go somewhere. But like what do we return exactly? Like what type signatures are you thinking of to say that it's returning a future? Like what is the generated code signature going to look like?
I mean, I don't think it's actually necessary for us to change all of the BIF signatures at this point. The only thing that's going to be effectively async from that wasn't before is going to be the implementation of, kind of executing a process. Right now we have this scheduler loop that, pops a process off, does some, setup or kind of just observes the state of that thing and then runs it. And then when that process yields back control to the scheduler, it finishes doing stuff, pops another process out the stack, swaps them, that largely remains the same. The kind of implementation difference here is that from the perspective of the scheduler, those processes aren't like special or, they're just futures. And what they yield is really, or when they are finished is when they've exited. So the value we get from a future here is just like the exit status essentially.
And I guess we don't really need to concern ourselves with Waker at all, unless we want to like handle the case where we want to like do a call to a future, which is like a runtime function, and then have that like wait on some like OS handle or something.
Yeah,
but I don't really know if that's actually the case. So we probably don't need the Waker at all.
The Wakers would be useful for two things, as far as I've observed after digging through a bunch of documentation. One is calling runtime functions that deal with async OS operations like IO primarily, which is definitely useful. And one thing that lets us do is when a process that is blocked on such a IO function yields, we don't have to reschedule it. That thing can stay off. The scheduler doesn't even care about it until the Waker says, hey, this IO is now ready, reschedule this process. And then we can deal with that however we want.
The Waker would just go into the scheduler, I guess, or like the process. Yeah.
We already have
responsible
Wakers
for rescheduling it.
Like the 200 lines thing, the example they give with the Wakers, like timer wheel is a Waker. You get a thing in your mailbox, Waker. Like we already have that, so we can adapt to use the Waker system for that.
I was just going to point those things out. And ultimately, I think the critical thing here is that we don't need to attempt to reschedule something that is not, it's just going to say, I'm not able to do anything, immediately yield back. You know what I mean? So that optimizes the scheduler quite a bit. The other thing I'm curious about is whether or not, let's say you call a process, then you're blocked effectively, at least until a timeout occurs, if there's a timeout. And in that instance, like we would be able to essentially have a Waker that says when that process is ready, you can wake back up the caller. Because until we've scheduled the callee, there's no point in even trying to interact with that process until the timeout has occurred.
I mean, Paul, the scheduler already works that way. like the I'm waiting for messages stuff. The timer wheel, like there are system timers already because I forget which BIF. One of the BIFs requires system timers, so not like I set a timeout, but like, and also the receive stuff we added, it already works that way. Like we don't try to rerun the scheduler unless we received stuff. Like they already do that.
But I guess the cool part is that we can really just unify everything under wakers. We can just ship wakers around and have those
like we have
handled.
features that are effectively our wakers, and like we have like the reactor and executor. It's just we don't call them that, but we can use the Rust stuff for it, and we'll probably benefit from that ecosystem. Like we already have those sort of things in, like built already. They're just not called that.
Yeah, I mean, I think the primary benefit here is that it is easy for us to unify async stuff in Rust with our own process mechanism. They appear to be uniform.
The one thing that it would be nice if the BIFs could participate in the I can spit out a future thing is there is a couple NIFs that like I've written that actually do queue up like other frames. And so if I could just use async for that to like do it, that'd be kind of cool. I don't know if that'd be compatible with all of them because like if we use async,
like an example off the top of your head of what you mean.
I want to say TC is done that way, and then some of them in web do that.
Probably also like handling like big chunks of binary. I imagine in some of those.
Yeah, I haven't done that yet, but it is like a known issue that like
but that's the case. We might
don't do those yielding BIFs, but like you know any place where like I have the label stuff with the macros, that's me breaking up one function into multiple functions to like queue up the next what would be the resumption points.
Sure, yeah, I see what you're saying.
Like anywhere you see that code, like that's the point where like if I could just literally say async and I made the BIFs have the same type signature as whatever the generated code's future signature is, it would just work, which would be cool.
Yeah, and as far as I'm aware, we can definitely recognize whether the result type of something is async from our generated code. I had made some notes on it. I don't remember the stuff off the top of my head right now because it's very like intricate. But as far as I'm aware, we can handle that if we want to. It might even be, the most naive approach is to just say these functions in our runtime are async. So handle them as async.
Well, I was just thinking if we support async in general, then we have that leg up over beam NIFs of like, it is very easy for you to write a yielding NIF. You just use Rust async and it's done.
Yeah.
Like that is super cool. And it also means that since we're async, but not in that weird way where you reschedule yourself, it's much more likely that you can call back into Erlang, which is a thing that beam NIFs can't do. And so that's an awesome feature too.
The main thing like that would be really nice if we could like even just having it so that you're allowed to hold term handles across like multiple reschedules. If we have that in our supported NIF API, then we're already like that's the big pain in the ass with the Erlang NIFs. Yeah,
because the current way that I did the breakup functions is it's like calling a new function just with new arguments, and then there's a special flag to be like, do I care about the return value of the last argument because it's on the stack or not? Or do I ignore it and just take the arguments you pass me? So, it's sort of like, am I a brand new statement or am I like a piped expression? And that's like the flag. If you look at how the WASM stuff I wrote does it, it's like the frames on there are that.
Do you have it so that you can like hold term handles inside like or do you have like a state machine structure for?
So the GC is set up where like it understands it looks into that structure to do the GC also. So yes.
Oh, so you still store them in like you still have to store terms in a way that the GC understands.
Yeah. So like each frame is like a vect. The arguments are a vect of terms, and the GC on WASM knows to Well, like not on GC, it's just an empty array, so it doesn't matter. So like technically on all targets, it does it. It
So I
walks
guess
through that, and then like, and the reason why that's nice is that on WASM, if I return term none, it knows that I either threw an exception because this was the thing where like because it had to be when we switched it to be like it only returns a term, we couldn't make it a Rust like type where like it was a union, a tag union or something. And so if it does term none, it's like it looks at was there an exception or do you have a bunch of frames queued? And if they're queued and it was successful without like having to do a GC, it'll be like these terms are valid. I'm going to put them on like your stack now, and then it'll play that because that way, a lot of the functions the way it works is I call you queue up like the next label to return to in the current function, but then also the function you actually want to call. And so then when this function returns, your label will consume the return value from that function. Is how a lot of that stuff is written.
I guess one of the limitations for us still, if we were to switch to the to having bits like that be represented as async functions, is that I'm guessing like if you wanted the ability for the GC to operate in between those like reschedules, then you can't like have terms on your stack at like yielding points.
Yeah, so that is one of the differences between like Rust code you'd write and the stuff that Paul's obviously can generate is he can make the resumption points like be GCable. Like I don't know how Paul, if you thought about like how is that possible, but
I mean,
that's an obvious possibility.
In the naive case, I was thinking, we leave the runtime non-async for the most part, except for in special cases, because then from our point of view, we don't have to do any special treatment. But if we, and actually, I'm not even sure. Like, I'm trying to imagine here. If we did a GC, let's say we can, yield from the middle of the Rust runtime code that's in the middle of doing something, maybe constructing a binary or something. And we want to do a GC when we suspend. I'm not sure if there's a way to make that safe, unless we can guarantee that, there's no pointers being held to terms on the process stack. If that makes sense.
Yeah,
I mean, if like if we're just talking like once we start talking about moving terms, I think there's like no way without having like Rust compiler support. But if we're just talking about like knowing if terms are live, like an option, but I don't think a good one is to go by like just scan the structure of the pointers and then just that's like the Bohem dumb GC way of handling it. But I don't think that's a good idea necessarily.
I have to jump off in 5 minutes. I have a call at 11. But I just wanted to add in real quick. It's a divergent from what you guys are talking about. I did have a chat with Francesco, and he gave me the pointers on getting an alternative runtime working group get started. We have to basically put together a proposal to submit to the EEF, and I mean, there's kind of bookkeeping activities required for the working groups. I don't think that I want to be the one to do that. I don't mind, helping get it started, but we may need to find somebody that, if we want to do a working group, that wants to kind of be the head of the working group.
I'm a member of the the NIF working group, which Zach I think submitted the proposal for, so I can ask him like what the proposal looked like at least if that's.
I have a template of the proposal.
Oh, awesome.
It's on the EEF website. I've already done work with the EEF through like the marketing committee, and I think outside of just getting everybody in the same chat periodically, I'm hoping there isn't too much else to the working group itself, but I also don't want to get bogged down in minutia of the EF's kind of what they put upon the working group leaders in terms of maintenance.
For the one I'm a part of, at least, we haven't had any meetings or anything. It's just been like mails back and forth. So at least that one hasn't been very high maintenance. But I don't know, like that varies.
Yeah, my exposure may be different, like the working group one. There were regular meetings, especially at the beginning when it was getting like the website and stuff up and running. So it could just be my perspective on it. It was a bit swayed from that experience. It may not be that, that much. But in any event, the first steps are there. So moving it forward. It sounds like there are some other people within Erlang Solutions that may be interested in participating in that working group too. So that's it for me.
All right. Well, yeah, I mean, I don't think I have time myself, unfortunately. Otherwise, I would probably try and do it. It's just I already have so much on my plate that I don't know where I'd find the time to do the working group stuff. Unfortunately.
No, I'm not asking you guys to do it. I think we would probably find someone external from the group. I don't want to add more things to the plate on top of building out Lumen.
All right. Yeah. In a normal year, I'd be like, yes, I'm all for it. I want to be involved. But I'm finding that I have just no bandwidth. It's the downside of not being at Dockyard anymore, I guess.
I mean, there's a lot of people at Erlang Solution, it seems, that are doing runtime stuff. So I don't know if there's someone there that might want to do it.
Yeah. I'll ask Francesco and just kind of get clarification on what the requirements would be to lead the group. If it's pretty low touch, I don't mind doing it. There's Lumen, there's Dockyard stuff, there's my own personal project, there's the other live view thing that I'm involved with. So I'm kind of spread thin at the moment, and just adding another thing on my plate is not something I'm looking for on a regular basis. But any event, I'll catch up with you guys in an hour at the lunatic call.
Good.
Okay.
All right.
See you then.
See you. Bye.
Bye.